Alrighty, let's see what we got here. Time for another streak to occur, hopefully. Alright, minimum distance between three equal elements, part 1, easy. You're given an integer array nums. Tuples I, j, k of three distinct indices is good if nums of I equals num of j equals nums of k. So values, so 3 spots where the values are the same in the array. Okay. The distance of a good tuple is the absolute value of I minus j. So how far apart I and j are, how far apart j and k are, and how far apart k and I are. The sum of those things or absolute value of x denotes the distance of a good tuple. Okay, yeah, okay. Good tuples are ones where the indices have values that are the same, and the distance is equal to how the sum of how far apart those three indices are from each other. Okay. Return an integer denoting the minimum possible distance of a good tuple. If no good tuples exist, return negative. Sure. Okay. So here 1 is the only value that repeats 3 times, so that's the only kind of good tuple that could be formed. And the distance here would be 2 from the first and the second ones, 3 from the first and last one, and 1, so 1 plus 2 plus 3 is 6. So here a good tuple could be for the 1s or the 2s. The 1s would be 1 plus 1, 2, 3, 4. 1 plus 4 plus 5, so it would be 10 for the 1s, and the 2s would be 2 plus 2 plus 4. So that'd be 8 for the 2s. Okay, so the minimum of those is 8. Yeah. Seems simple enough. So first I'll need to identify all the values that appear 3 times. And then for each I probably want to identify the locations of those things. If you want to calculate the minimum distance, you'd use, if there were like 4 1s, like there's 3 1s here, but there was another 1 down later on, you want to use the 3 closest ones or the ones that are consecutive within that 4. The 3 closest consecutive ones. So it doesn't make sense if you're just like doing the first, the middle, and the last one of a very long list of ones, something like that. Okay, so I think what I'm going to do is I'm going to, for each value, find all the indices of that value. How many values are there? Pretty small. Okay, this is the easy version, part 1, probably a harder version, part 2. So for each value, have a list of indices, kind of positions where it occurs. So let's go ahead and say positions is equal to a default dictionary of list. The key is going to be the value, and the probably use key is the number, and the value at that key is the list of positions. So for every index in range n, where n is the number of numbers, I'm going to go ahead and say position of this value. The value is the nums at this index. The positions of this value appends this position, this index. I'll just go ahead and verify that this is doing what I expect it to. So for example 2, it'd be like 1 would give you 0, 1, and 5, something like that. 0, 1, 5, yeah. And then 2 would give you 2, 4, 6 for those positions. 3 would give you 3. Okay. And then let's say answer is equal to infinity. Since we're trying to minimize it, start off high. Yeah, I think if the answer is still infinity after the loop, then we'll return -1, otherwise return the answer. I guess I should probably put this in a combined statement. Return answer if answer not equal to infinity, else return -1. Okay, so the for loop would be for every, I guess, unique value in the nums in the position default dictionary, if the length of the number times this length of the list, the number times this occurs, is going to be less than 3, then skip it, right? Less than 3. Skip or continue. Okay, so now we're dealing with the ones that are at least 3. So I guess maybe I'll do is there a fast way of doing this? So there's 3 distances. There's 3 distances. One distance is always going to be the same. I'm trying to think of the way to iterate over the list of positions for a particular value to get the summation distance. So something like, let's say position 1 is, okay, let's say the array is going to be position of this value. And let's say P1 and P2 is equal to array 0 and array 1. So how to do this? So you go P, maybe distance 1 is P2 minus P1. And then for every later P3, so for every for every P3 K in range index 2 to index length of array. P3 is equal to array at K. And then what? And then I say D2 and D3 is equal to P3 minus P2 and P3 minus P1. And then the sum is the sum of D1, D2, and D3. So answer equals min of answer and P1 plus P2 plus P3. And then you shuffle the values off. So like P1, P2, D1, E2. I'm going to recalculate. So I think I only keep D3. So yeah, so D1 is going to be P2, P3, and D3. Rotate off P1, that becomes position 2. I'll rotate off position 2, it becomes position 3. And then rotate off D1, that becomes D3. Okay, I think that's right. I think that might be it. Ooh boy. 5 instead of 6, 6 instead of 8. Huh. How odd. P3 minus P2, P3 minus P1. Oh, whoops. Oopsie, this should be distances, D1 plus D2 plus D3. Okay. Oh, shucks. So this should have been 4, but it was 6. Yeah, 4 would be the last 5. That would be 0, 1, 2, 3, 4. 2, 3, 4 the positions. Why did this not work? Answer equals the minimum of answer in D1, D2, D3. Okay, let's double check here. I guess I'll put in the value as well, so it'd be value. So it should read something like 5, 0, 1, 0, 2, 3, and 5, 2, 3, 4. Okay, so it's just miscalculating it. 5, 2, 3, 4. Oh, whoops. Did I make a mistake here? Oh, I have to make a mistake. It doesn't seem like I recalculated D1 like I should. Yeah, D1 needs to be recalculated each time. Whoops. Whoops, whoops, whoops. No, D1 was D3. Whoops, that should be D2 here. Whoops, whoops, whoops. Should be the 1 and 2, and then 2 and 3. It replaces 1 and 2. Oh, that was bad. Whoops. I guess I didn't need to remove the D1 part. Or I should have removed the D1 part. D1 is equal to P2 minus P1. Ah, shucks. Shucks, shucks, shucks. Now that I think about it, I'm pretty sure I just need the first and last, right? Because the middle distances combine to the longest distance within it, right? So like from this one to this one versus this one to this one is the same as this one, the first one to the last one. Okay, so I'm extra. I can just simplify the calculation. It's just going to be twice the distance from like the first position to the last position, P1, P3. So P1, P2, I don't really care about P2 even. Do I? I think I can just, okay, I don't need all these variables. Oh, it's probably slowing down from the print as well. Yeah, the print is probably unnecessary. Answer equals min of answer and 2 times array at k array at k minus array at k minus 2. I think that's correct. Okay. And let's see if the print also might have messed it up, right? Okay, so still not fast enough. Answer equals the min of answer. Okay, let's go ahead and just replace this with the if statement. If answer is less than 2 times array at k minus array at k minus 2, answer equals 2 times array at k minus array at k minus 2. Did I mistype this? Oh, it's the other way around. Oopsie. Okay. Interesting. I wonder if sorting it. No way sorting it should be faster. So for every index, okay, I'll go ahead and just remove one statement here. The value is just the nums at this index, so position for the nums at this index is equal, appends the index. For every value, if there's less than 3, skip. Array equals position at this value. That's fine. For everything past 2, I mean, I could just do everything up to length of array minus 2, something like that. So maybe that's slightly length of array minus 2. I think that's right. And then I just need to change this to be from k plus 2 minus array k instead of the other way around. Not sure if this actually changes much. Changes anything, really? I mean, I guess in theory I can just do something like also remove the multiplier by 2 and just keep the distance between the first and last and then return twice the answer. Return 2 times the answer if answer not equal to infinity. Okay, I think that's, I mean, how much is that computation actually slowing things down? I doubt it's slowing anything down. Alright, well, I randomly got a fast solution. I think it's all kind of just whatever. Somehow my memory increased even though it's the same freaking thing. Okay, anyways. Okay, summary. Used a kind of use a tracker, which is going to be a default dictionary of lists for all the positions that every unique value occurs in the array, in the nums array. Only values that occur at least 3 times can form a good tuple. So, i.e., the length of the kind of dictionary for that value needs to be at least 3. Then for each position, or for each array of positions of a value, of a unique value in the array, iterate over kind of the possible kind of first and third. So iterate over the possible first and third and find the minimum distance, as the total distance will be twice that difference. So for example, if you have p, the first position is like 0, or say 2, second position is at 5, actually wherever, and third position is at 10, then the distance is going to be equal to 10 minus 2 doubled, which is 16. Because whatever you pick for P2, like say you pick 5, 5 minus 2 is going to be 3, 10 minus 5 is going to be 8. That's the same distance as from P2 to P1 plus P2 to P3, that's going to be the same distance as P1 to P3, regardless of whatever P2 is. So P2 is 9. 9 to 2 is 7, 9 to 10 is 1. That's also 8, which is again the same distance from the first to last. So return return that minimum total distance after finishing all possible kind of combos. I guess kept track of the minimum difference between the first and the third positions, and then return twice that minimum distance. I guess that'd be the minimum total distance for all 3. Alright, time complexity is going to be O of n to iterate over all the elements and form the default dictionary of lists of positions. Yeah, this is O of n right there. And then similarly, there'll be O of n to iterate over those positions again to determine the minimum distance. So overall, it's O of n. Basic complexity is to be O of n to store the default dictionary of positions, which will have at most n entries. Well, no, technically we'll have, which will have all